Hello students, this is Shachi. Welcome to my channel Crack Chemistry. Today's lesson Solid State Part 2 is for class 12, in which we will learn about crystalline and amorphous solids. General characteristics of solid state have been explained in part 1 of this chapter. So for general characteristics, please refer part 1 of this chapter. The link of part 1 has been given in description box. Students, before starting, I want to remind you to subscribe my channel for getting information about further important uploads, and don't forget to like and share this video with your friends. So now let's start the topic. Today we will learn about amorphous and crystalline solids. Students, solids can be classified as crystalline or amorphous on the basis of nature of order present in the arrangement of their constituent particles. So, criteria for dividing a solid into two categories is the nature of order present in the arrangement of their constituent particles. So, we will start a discussion with crystalline solids. Students, crystalline solids usually consist of a large number of small crystals, and each crystal has a definite characteristic geometrical shape. The arrangement of constituent particles, the constituent particles may be atoms, molecules or ions, in a crystal is ordered and repetitive in 3 dimensions. So we can say that a crystalline solid consists of a large number of small crystals, and each crystal has a definite characteristic geometrical shape, and the arrangement of constituent particles in a crystal is ordered and repetitive in 3 dimensions. So, if we observe the pattern in one region of the crystal, we can predict the pattern in any other region of the crystal. So, we can say that crystal has a long range order. Long range order means there is a regular pattern of arrangement of particles which is repeated over the entire crystal. Sodium chloride and quartz are typical examples of crystalline solids. Now we will learn about amorphous solids. Glass, rubber and many plastics, they don't form crystals when their liquids solidify on cooling. So they are called as amorphous solids. The word amorphous comes from a Greek word amorphos, meaning no form. The arrangement of constituent particles, which may be atoms, molecules or ions, in such solids has only short range order. Short range order means there is no regular pattern of arrangement of particles. In such an arrangement, a regular and periodically repeating pattern is observed over short distances only. Regular patterns are scattered, and in between the arrangement is disordered. The structure of amorphous solids is similar to that of liquids. Now we will see two-dimensional structure of quartz, which is a crystalline solid, and quartz glass, which is an amorphous solid. Diagram A represents arrangement of quartz, which is a crystalline solid, and diagram B represents arrangement of quartz glass, which is an amorphous solid. If you look at these two structures, initially you may think that these two structures are identical, but if you look carefully, you will find that in case of a structure B, which is a structure of quartz glass, it is not having long range order. So till now you are clear that crystalline solids and amorphous solids, they differ in the pattern of arrangement of their constituent particles. Now because of difference in arrangement of constituent particles, the properties of crystalline and amorphous solids will also be different. So first we will learn about characteristics of crystalline solids. Crystalline solids have a sharp melting point. Sharp melting point means at a characteristic temperature they melt abruptly and become liquid. One more property is that crystalline solids are anisotropic in nature. Anisotropic in nature means if some of their physical properties like electrical resistance or refractive index is measured along different directions, we will get different values. So what is the reason for anisotropy? The reason is different arrangement of particles in different directions. Anisotropy I will explain you with the help of the following diagram. This picture represents the arrangement of particles in a crystalline solid. You can see here that if we measure any property along the direction AB, you will come across similar type of particles. But if you measure these properties along the direction CD, you can see that you will come across different type of particles. So the reason of anisotropy is the different arrangement of particles in different directions. If you measure mechanical properties such as resistance to shearing stress might be quite different in different directions. For example, deformation in direction CD displaces rows which has two different type of atoms. You can see here two different type of atoms are here in this row. But deformation in the direction AB displaces the rows which are made up of only one type of atoms. So I hope this is clear to you. What is the reason for anisotropy in case of crystalline solids? The reason for anisotropy in case of crystalline solids is different arrangement of particles in different directions. Now we will learn about characteristics of amorphous solids. Contrary to crystalline solids, amorphous solids soften, melt and start flowing over a range of temperature. Means they don't have a sharp melting point and they can be molded and blown into various shapes. Amorphous solids have the same structural features as liquids and therefore they are conveniently regarded as extremely viscous liquids. But they may become crystalline at some temperature. Students, the point which I am going to discuss right now has been asked in your board exam. This is your NCERT question also. Some glass objects from ancient civilization are found to become milky in appearance. Why they become milky in appearance? Because some crystallization has taken place. So, amorphous solids may become crystalline at some temperature. Like liquids, amorphous solids have a tendency to flow but very slowly. So therefore sometimes these are called as pseudo-solids or supercooled liquids also. Because of this property to flow, you might have noticed that window panes at the bottom become thicker. Another property is that amorphous solids are isotropic in nature. We have discussed that crystalline solids were anisotropic in nature, but contrary to crystalline solids, amorphous solids are isotropic in nature. It means that if we measure their properties such as mechanical strength, refractive index and electrical conductivity, we will find that they will be same in all directions. What is the reason for this isotropy? The reason is that there is no long range order in them and the arrangement of particles is not definite along all the directions. So the overall arrangement will become equivalent in all directions. Therefore, value of any physical property would be same in any direction. Now we will learn about polycrystalline solids. Besides crystalline and amorphous solids, there are some solids which apparently appears amorphous, but they have microcrystalline structure. These are called as polycrystalline solids. Metals often occur in polycrystalline condition. So what are polycrystalline solids? They look like amorphous solids but they have microcrystalline structures. Individual crystals are randomly oriented. So a metallic sample may appear to be isotropic just like amorphous solids, even though a single crystal is anisotropic just like crystalline solids. Now we will learn about uses of amorphous solids. Students, amorphous solids are useful materials. Glass, rubber and plastics find many applications in our daily life. Amorphous silicon is one of the best photovoltaic material which is used for conversion of sunlight into electricity. Now in the last, we will discuss differences between crystalline solids and amorphous solids. The differences between crystalline and amorphous solids have been mentioned in this table. We will start our discussion with shape. So in case of crystalline solids, they have definite characteristic and geometrical shape, but amorphous solids have irregular shape. Now we will discuss melting point. As we have already discussed that crystalline solids melt at a sharp and characteristic temperature, means they have a sharp melting point. But amorphous solids gradually soften over a range of temperature and they don't have a sharp melting point. Next property is the cleavage property. Crystalline solids, when cut with a sharp edge tool, they split into two pieces and the newly generated surfaces are plain and smooth. But if amorphous solids are cut with a sharp edge tool, they cut into two pieces with irregular surfaces. Next point is heat of fusion. Crystalline solids have a definite and characteristic enthalpy of fusion, but amorphous solids, they don't have a definite enthalpy of fusion. Next property is anisotropy. Crystalline solids are anisotropic in nature, but amorphous solids are isotropic in nature. These properties I have discussed in detail. Then next property is nature. Crystalline solids are true solids, but amorphous solids are pseudo-solids or superpooled liquids. They are also called as extremely viscous liquids. And the last point is order in arrangement of constituent particles. Crystalline solids have long range order, but amorphous solids have only short range order. Students, I hope each and every point is clear to you. Please post your doubts in comment box. Don't forget to subscribe my channel. Please like this video and share this video with your friends. And don't forget to watch part 3 of this video, in which I will discuss some NCERT problems with you. Thank you so much. Have a nice day.